Number 13a, using first principles, find dy dx of the function f of x equals to 3x squared. This is a number from differentiation, and we need to find the derivative of this function here, f of x equals to 3x squared, using strictly first principles. So the solution is, since we are given the function f of x as 3x squared, and we need to use the method of first principles, the formula that we apply when we use first principles is the derivative dy dx of any function dy dx is equal to it is given by limit as h tends to 0 for the function f of x plus h minus the function f of x, all of them, all over h. This is the formula that we apply when we are using first principles. There is also another format of using small changes. It also works, but I do not encourage it simply because it confuses students, and this method is direct forward, and they are the same. Now from here, we simply need to find the function f of x plus h, and then we are given the function f of x, and then we substitute for them in this formula. So for us to find f of x plus h, what we do is we say we are given the function f of x as 3x squared. And then how do we get f of x plus h? F of x plus h from here. Simply what we do is, wherever we find x in this given function, we put x plus h instead of x. So we simply say our x now is x plus h. So where you see x here, you put in x plus h. Like in this case here, we shall have 3, but where there is x here, we substitute for it as x plus h. This is x alone, but then we square it. So it will look like that. And then we simply expand. On expanding here, I'm going to keep 3, and then I expand. What is x plus h squared? That is the same as, I believe at this point you know expansion, and in case you don't, visit our playlist of Senior 3 Basic Mathematics. The expansion of this, without wasting time, becomes x squared plus 2xh and then plus h squared. That is the expansion of that. And then we multiply by 3. Multiply all the terms now by 3. That gives us 3x squared plus 6xh plus 3h squared. We are multiplying by 3 because there was a coefficient of x squared given us 3. So we are expanding everything. So this is the expansion. And therefore, this is the function f of x plus h. Now we have the function f of x plus h that we needed to substitute here. And the f of x here is the given function. And now from there, we simply substitute for them in that function. So we shall now say, therefore, our dy dx equals to limit as h tends to 0 for the function. What is f of x plus h? It is here. It is 3x squared plus 6xh plus 3h squared. That is f of x plus h. But the formula says that we subtract away f of x. What is f of x? F of x is 3x squared. F of x is a single term. It is one term. But if it was more than one term, then we put it inside a bracket. But remember, all this is over h. Divide all the terms by h. And then from here we further simplify. So this equals to limit as h tends to 0. I will explain for you how this part of the limit will disappear. Into we simplify this. I'm saying here 3x squared here and 3x squared here are going to subtract and give us 0. So they cancel out. I don't encourage you to cross your work like this in exam, but I've done it already just for now. So those will cancel, and then we shall be left with 6xh plus 3h squared over h. And then from here we divide all the terms by h. So we shall have limit as h tends to 0 for what is, remember we distribute the denominator. So let me show that. We shall have 6xh out of h plus 3h squared also out of h, right? And then we simplify that. So we shall have limit as h tends to 0 for this h and this h are going to cancel. H and h will cancel, so here we shall be left with 6x plus 1h will cancel here, so we shall have 3h. Now at this point we are saying limit as h tends to 0. So as h approaches 0, so as h tends to 0 or as h approaches 0, then we come and substitute for the value of h in this expression. Therefore our dy dx equals to, now when you are tending h to 0 or as h approaches 0, you don't show the part of the limit. Therefore here we shall just have 6x plus 3, but what is h? H approaches 0, so we substitute for it as 0 as it approaches 0. And then from there we simplify. Therefore we shall have 6x, 3 times 0 is 0, and finally our derivative becomes 6x. So this is the derivative that they wanted, and that is the dy dx. So that is how we use first principles. We have very many examples that we have done in differentiation from the beginning up to the application. So you can find time and visit our list of videos on this same channel. Thank you.